Welcome, everybody. Good morning, good afternoon, good evening, depending on where you have joined from. Today, we are beginning with the first webinar in this series by Markus, and the topic is calculated column versus measure. Let me just quickly talk about our big mega upcoming virtual summit. And I think all of you know about this already, so I'll just go over very quickly. Data Platform Virtual Summit 2021 is now announced, and it is in the seventh year of this conference. It focuses on Azure Data Stack and SQL, Power BI, Synapse, ADF, and all the goodness that the Azure Data Analytics and AI portfolio brings. And the best thing we have done this time is we have made the summit free if you just pick up any one training class. So we have 15 training classes that are scheduled for you. We call them as pre-cons and post-cons. Some of them are pre-cons, which means they happen before the summit, and some of them are post-cons, which means they happen after the summit. 8 hours of duration, 2 consecutive days, 4 hours each day. And here is the run-up of all the classes that we have for you, 15 of them there. And I will not call out each one of them, but of course, specifically, I will call out Markus's class, which is on DAX. And this is the one he is doing at DPS 2021. So we reached out to Markus and we said, hey, you're doing this class. Why not also deliver a webinar where we can even let your audience know about the class? So yeah, friends, go to dataplatformvirtualsummit.com. The link is there in the chat window. Explore everything that DPS has to offer, and keep in mind, for a limited time, you take up a training class, you get the summit free, you get all the recordings absolutely complimentary. So yeah, a lot of goodness. All demand for the on-demand access for next 12 months. Content has been the king for us at DPS. We have had always great focus on the content, and the breaking news as of last week is that we have released more than 100 breakout sessions from the community, from MVPs, and from Microsoft. So go to the website dataplatformvirtualsummit.com, hop over to the sessions section, and you can browse all the sessions that we have released. So yeah, a lot of great content out there. Yeah, so do not wait. Go talk to your managers and sponsors and your company and get on board today. Well, some social links for you there. If you are on Twitter, LinkedIn, Facebook, YouTube, we're everywhere. Feel free to follow us wherever you feel comfortable and continue talking to us. Our Twitter is The Data Geeks and at the rate SQL Server Geeks. I mean, these are twin communities, so to say. So feel free to follow us or join us wherever you like. Well, with this, the wait is over. DAX, calculated column versus measure, very specialized topic. I would never expect hundreds of folks to come and attend this because this is very specialized, and I'm so happy that Markus gave us this topic. Markus has been working in the IT computing industry since 1996. I mean, he has done everything. He's an MVP, MCSE. He runs an own company into consulting, training, and is all over the place when it comes to Power BI. All leading conferences will have Markus as a speaker. So we are truly honored today to have Markus. Markus, over to you. And thank you so much for joining us.
Yeah, thank you very much. The pleasure is all mine. Yeah, welcome to DAX, calculated columns and measures. And I think this is an interesting topic because when you learn DAX, like most parts are very easy to learn, but there's always this question, when shall I use your calculated column? What's the consequences? And when should I prefer measure? So we came up with a full talk about that. So we'll concentrate only on a small portion of DAX on calculated columns and measures. So what is this all about? Let me skip the next slide. Yes. Very good. So DAX, calculated columns and measures, that's what I already talked about. And then there's DAX is called the data analysis expressions, sometimes referred as the data analytic expressions. And born DAX, or even Power BI Desktop, was born with as an add-in to Power Pivot. So DAX took a lot of ideas and concepts over from Excel, and it lives also in Power BI Desktop, of course, and also in Analysis Services Tabula. So if you're a back-end developer designing Analysis Services databases, then you also have to learn DAX if you want to have all the full features of Power BI and Analysis Services available. And calculate measures and columns, yes, make a big portion of that. So DAX is influenced by many languages. So they just took, like Microsoft, like DAX is the newest language of all those analytic languages or tools. And so it just took the best of all, the best of breed, so to say. So it took over from Excel, the function-based syntax. So everything is a function. So even like if you have an if then else, this is a function with 3 parameters like in Excel, and 100 functions share even the same source code. So that just took it over from Excel. There's other concepts like the relational, that there are relationals in the data model, and there's relational functions, and also the concept of a row context. They have like that we calculate something row by row. This was taken over from SQL. If you like a SQL expression, select something, and then you have like a formula expression. This is then evaluated row by row, and for every single row of the table you're returning, this expression is then evaluated and shown. And from the MDX, they took over the concept of measures, of implicit joins. So usually in DAX, in many cases, we don't write any joins. We just use the columns from different tables, and DAX under the hood will take care of joining those tables. And also the concept of a filter context. So we have one measure, one formula, and depending on in which filter context it is evaluated, it will return a different number. So the formula is the same, but the result would be different. New thing is this context transitioner. This is the hardest part, and we will see how far we're coming. So this talk is like built up in levels. So I'll try to take you from a very ground level, start with calculated columns, and then I will explain things, and I hope you understand those things. And then I will challenge your understanding and will bring you to the next level. So let's see how far we come today. DAX is used, of course, for measures and calculated columns. That's the talk about. That's what the talk is about. And I made sure that I color code everything. So anytime something is in blue, or you see like this icon, this calculator, then we're talking about measures. If anything is in orange, or like this FX icon, or whatever you would call it, appears, then we're talking about calculated columns to make it really transparent what we are talking about. DAX is also used for calculated tables, row level security and queries, but that's not what we have. I will have time for today, but of course in my workshop in September. So the syntax is quite easy. Just functions calling. You call functions with parameters, and of course one of the parameters for a function can be another function. So you can wrap functions inside of functions. But the syntax is quite easy to understand. It's not very complicated. The complexity comes with the semantics, so the understanding what the function does, that you know what are the consequences of that. Is this faster or slower? And the complexity for beginners is like, yeah, a bad thing, because you're fighting against the complexity and try to understand things. But in the end, it's very good that there's complexity there, so we can have really, really powerful computations with DAX. For this 60 minutes, I took 3 calculations, and this is just random calculations, more or less. And I took over the sales amount. This is a number I always use in many of my projects. I do business projects, then have the sales amount there. And I want to make sure that everybody understands how this is calculated, because the struggle here is not, hopefully, not the formula, but how we can translate this then to DAX and implement it in DAX. So the sales amount, if you have the price and the quantity, you have to multiply the price times the quantity, and then sum all those rows or whatever the products or your customers or whatever up. So price times quantity is the sales amount. We could also calculate the margin. The margin is what is left if you subtract your costs from the sales amount. So sales amount minus the total cost, that's what we usually call margin. And we can also calculate the margin in percent, and in percent in this case means in percent of the sales amount. So when I have a margin of 10%, this means if I sell something with 100 to a price of 100 of whatever currency, 10% would be the margin. That would mean we have costs of 90. So the leftover after subtracting the costs is 90, and in percentage, that's then 10%. If you're not quite sure, if you're insecure about those calculations, please do a screenshot right now. Make a screenshot of that and keep it on the second screen, or just as a second application, so we can refer to that. So we have an easy time then to concentrate on DAX and not on the formula. There's the first question. If we cannot specify joins in DAX, yeah, and it's from data model, how do we decide to use inner joins at time versus left joins based on particular SQL statements requirement? Very, very good question, Isa. The thing is that Power BI for us by default always does outer joins, and the reason for that is nothing should be get lost. So if you have, for example, you have like a sales and there's a data quality issue, and your sales is referring to a product which is not available in the product table, then the sales will not disappear. It will always appear. As there is no product where it can refer to, it will show up on the blank product. So all the rows which violate the referential integrity in a relational database, they are not lost, but they're summed up with a blank row. I hope this did answer your question. If not, please let me know. So especially in BI, I would say we always want to see everything. We do not want to lose anything. And in SQL, you would like performance tuner try to have inner joins because they are faster. But in some cases, you have to use left joins because there's data quality issues. And Power BI takes care of that it's always using the outer joins. Okay, thanks, you did. Very good. So if there are questions, remember, if you're watching this live, this is a live event. Please talk to me, ask questions. You're not, not the YouTube video. Of course, if you watch the recording, it's a YouTube video, but up to that, it's a live event and you can ask questions. So calculated columns. As mentioned, I color-coded everything. So the slide deck and also the examples calculated in orange, and those are these colors and the icons up there. By convention, if you refer to a column, we should always refer also the table. In some cases, we do not need to refer the table name as well, but you should always do because you want to know that you're handing you're facing a calculated column and not a measure. And usually I put all the table names in single quotes. This is not strictly necessary. So for example, a table called sales, you can omit this, the single quotes. But for example, for a table called date or product, as there are DAX functions available with the very same name, date and product, you have to put it under single quotes. Or if you have like special characters, like a blank, like you have reseller blank sales as a table name, there's a blank in it, then we have to put the single quotes. That's why I try to always use the single quotes to mix up things and make it even more confusing. Then this sounds a little bit stupid because we're talking about calculated columns, but they're calculated row by row. This sounds like there's an error in here. No, it is not. It means that we have one formula for the column, and this formula is executed and evaluated for every single row of your table. That means that this is then called a row context. We'll hear about that again later. And it's really statically persisted into the models. That means if you add calculated columns to your model, that means that your Power BI file, your Excel file, or whatever we're using the calculated columns, or your analysis services tabular model will get bigger. So it will uptake more space. If like the Power BI file will take more space on disk, and it will also need more space in memory, because it's calculated and persisted, and it's updated during the model refresh. So if you have the refresh button, then everything is calculated and then stored inside of the model. So that means that the file gets bigger, but also the refresh takes longer. So this is one very important thing to know. And on the other hand, the calculated column will not change. If you apply filters or something in your report, the individual calculated values per row will not be filtered or changed. The only thing you can filter on is that you show more or less of the rows where the calculated columns is then part of. But the calculation itself is not influenced by any filter. The data type is then automatically discovered by Power BI, and we can change it if you need this. We're concentrating on numeric calculated columns. And also very important, if you publish this like as analysis services or as a Power BI data set, or you can even open up a Power BI desktop file and then connect Excel to this Power BI desktop file. Anyhow, if you're using Excel to consume a model, then we will discover that you can put columns, calculated columns, and natural columns, so to say, into the columns, filter, and row fields section of your pivot table, but not under the values. If you need this, then you will have to implicitly write a measure. which we'll learn about later. Power BI makes this sort of easier, but in some terms, it's sometimes more confusing because things work in Excel different than in Power BI, even connecting to the very same data model. Because Power BI creates an implicit measure. So if you have a calculated column, then if you do not change anything, then there will be a default summation set to sum. So it will create an implicit measure for you to summing up those things. This measure is invisible, we cannot see it, but we can change the behavior with the default summarization option. So that means we have under the modeling option, we can change what kind of default summarization we want to have for a calculated column. So sum, average, minimum, maximum, count, and count distinct. And this is independent of what you have in your visual. And your visual, you also have options like sum, average, maximum, minimum, maximum, count, distinct, and count. So I don't know why the order here is different. And as we can see here in the report, we can even reach out to standard deviation, variance, and median, which is not available as a default summation in the model. I don't know why. Most probably two different interns worked on this feature. That's what this looked like. So this is hidden, but we have control about that. And if you do not want to summarize it, like for the calendar year, I do not want to have a sum over years. This does not make any sense. Then you would change it to do not summarize. If this is set, then Power BI will create an implicit measure with exactly whatever you've chosen here. So it will create a measure for you, hidden one, and it's so hidden that not even Excel can discover it. So Excel is not using it because it's only a Power BI feature. So let's come to the first example. We talked about that I want to implement with you the sales amount, and sales amount is the price times the quantity. Again, orange, this is a calculated column. We see the icon up there, and I used the table names in here, so also make it clear this is a calculated column. I could omit, as mentioned, the single quotes here, but I try to always have the single quotes there to make it easier to read. So price times quantity. If we take a very easy example, and this is the example I'm having here, this is a table with only 4 rows. A sales table with only 4 rows, as we can see here. For the first of the month, we have 2 different rows, and then for the second and the third, that's everything in there. So quite easy. So we can even recalculate with our brains. We don't need any tools for that. And as you can see here, with the price and the quantity and with the sales amount, and this new column is the sales amount. This is the formula we can see here. So price times quantity, 10 times 3 is 30. That's what we get out of that. Makes sense. 10 times 1 is 20. 30 times 4 is 120. And 100 times 5 is 500. This is what is stored in the model. The model, or the table. The table does not know anything about what kind of visual later it will be used in. So what we can see here, this is a report, and this report is a table visual. So this is not a table in the model. I'm talking about a table visual. And this table visual has a total at the end, and this total is calculated over the implicit measure. So the 670 we're seeing here is calculated at 30 plus 20 plus 120 plus 500, which is 670. Very right. So very important. We have calculated columns. These are persisted in the model, and in the report, we usually face, in many cases, then the implicit measure, not the calculated column, and the implicit measure is calculated or controlled over this default summarization. So easy as that. Let's see to the next example, the margin. Remember, the margin is the sales amount, and then we subtract the total cost from it. So that's what's left over from the revenue we're receiving, and we have costs, and what's left over. That's the margin. And this is also calculated as a calculated column. Again, in this case, we only see three rows because the Power BI is very good in like aggregating things. So it's already grouped by the date. So we have the sales amount of 50 for the first day. So this obviously was 2 different products, the total cost of 40. And if we subtract those values, then we end up with 10. 120 minus 75 is 45. 500 with 350 is 150. And then there's this question of the total again. In this case, for this formula, it doesn't make any difference if I sum up the results, like 10 plus 45 plus 150 is 205. Or I could also subtract the totals here. So 670 minus 465 is also 205. So we can try to recalculate this. So in this case, it doesn't make any difference. As we're currently facing a calculated column, we remember calculated column has an implicit measure, and this means that the 205 are calculated vertically over this implicit measure, which is summing up those three values here. So it's not calculated this way. In this case, we don't care, but sometimes it could be surprising or wrong, or there could be discussions which is right. In this case, there is no discussion because it doesn't make any sense, but we should know, we should be aware, as margin is a calculated column, it is summed up in this way. Okay, any question to this point? Please let me know, because we are coming now to the a little bit more complicated thing, which is now before that, we talk about the calculated column and the row context. I used this term previously, and the row context means that the calculation of something is executed row by row, and every calculated column is always evaluated row by row. So, for example, the sales amount or the margin, this is evaluated for every single row of the sales table. The price of some row and the quantity of the same row is taken, multiplied, and then stored in the same row in the column sales amount. And the same is true for the margin. So per row, the sales amount is looked up, the total cost is looked up, and then the subtraction happens, and this is then stored and persisted as column margin in the table. So the margin percentage is a little bit more challenging. So margin in percentage is the margin divided by sales amount. To be mathematically correct, we also would have to multiply it with 100, but instead of that, in Power BI, we can mark it as a percentage, and it will automatically be done. So we do not have to multiply it with 100. So margin in percentage means 5 divided by 20 is 25. This is right. And 5 divided by 30 is 16 point something, and 45 divided by 120 is 37.5, and 150 divided by 530. Very good. So this is right, but we have an issue here with the 109. So I'm not sure what your expectation is, but again, remember what the margin in percentage is, or what the margin is. The margin is what's left over if you subtract the cost from the sales. And margin in percentage is the percentage of the sales. So margin over 100, margin in percentage over 100% means that if you sell goods for 100 whatever, the leftover, that's what we can keep, is 109. This would be a perfect business. So if anybody of you finds out how we can do that, selling goods for a certain amount, but like at the end, having more money than we received from the customers, this would be a perfect business. I would love to hear, and we should have to talk about that. I'm quite interested in it. So far, I did not find any solution for it. So obviously, this number is wrong, because it's hard to do a business earning more money than it's receiving from the customers by selling goods or services. The reason here is because there's this implicit measure. Remember, this is a calculated column. Only the individual values are stored in the tables. In the report for the total or every other grouping, the total is just one of the groupings. We could have different groupings by year or month or by product or by region. Then the implicit measure comes into place and sums these things up. So this is wrong. What would be right? And sometimes I have this discussion, like people say, yeah, of course, this is summing up. We are not allowed to sum up the percentages. We have to calculate the average of the percentages. So let's take a look. What's the right number and what's the wrong thing here? Let's go to my report here. So the first thing, and this is what I already shared with the guys at DPS. So you should have already access to it. This is the data model I'm facing here. So this is like the 3 rows here: product ID, price, quantity, total cost. That's it in here. And I have a simple product table with 4 products. One of those, the 130, is never referred here. So this is a product which don't sell anything. And then I have a date table here consisting of the previous year and the current year. So it's starting at January 1st, 2020 and reaching down to the last day of this year. So 31st December. Yeah, there's even like one day for the other day, for the other year. Well, let's go to the sales margin, the issue we're facing here. So again, we have the formula in here. This is only like a text box here showing you the formula, so I don't have to open up the formula there. And then we see this is the margin in percentage, and the margin is then by default grouped. So we can see here, like we only see one entry here for the 1st of July, even if there's 2 rows in the table. Can we get rid of this here? So this is a sales table, 2 rows there, and Power BI usually groups things. So we are seeing like 10 and 50 here, and 41 is also wrong. Like if the margin is 10 and the sales amount is 50, this should be 20% and not 41%. The reason is because this is summed up. So if I go to my visualization, the margin, I could change it easily here from, I hope everybody can read this. So let's zoom in here. So currently this is sum, the default summation, and I could change it to average if I want. And I can do that. So I can change it to the average. Then usually the name changes, average of margin, and then we are seeing a different number, like 27. 27, I would say, is closer to what I would expect, because I would expect for the average of the margin, or the margin, that they cannot be bigger or smaller than biggest or bigger than the biggest or smaller than the smallest value I have in my rows. It has to be something in between. But what's the right number? So I would be a really, really bad consultant saying, yeah, I think this looks right. This is not the way I work. So how can we calculate? What's the right number there? Does everybody know how we can, what's the right number? What's the number we have to have here? I hope so. So the reason, or the right number, is that we have to replicate the same formula we're having for the individual rows, we also have to do on the total row. So what everybody would expect, everybody I know would expect from the margin percent for the total row would be to divide the 205 by the 670. So 205 divided by 670 is 30, like times 100. That's what we can do here. So 30.6. This would be the right number. 27 is closer and better than 109 for sure, but it's still not the right number. And the more different the individual margins are, the more this average will deviate from the right number. So I would not publish any report with the 27 here. I would try and do everything I can do to make it the right number, which is 30.6%. So how can we do that in Power BI? The solution is, with a calculated column, we cannot, because the calculated column is calculated by the individual rows, and then with the results, we can do something. But we cannot pass in a formula for a calculated column, which is then replicated for the total. This is not possible with a calculated column, because the calculated column only lives within the table and does not know anything about reports and table visuals and so on. The good news is we can have explicit measures. So instead of trusting this implicit measure built by Power BI, we can explicitly write a measure. And measures are usually here, the color code here is blue, and this calculator up there. The convention is that we use the measure name in brackets, so we omit the table name. So if with one side we can see this is a measure, this is not a calculated column, this is important. And I think of a measure as something which lives detached from your data model. So like the measure, if I would be a measure, I would see the total, the whole data model in front of me. So, and usually I don't see everything, all the content of all the tables, but those tables, the content of those tables are filtered because there's a filter on the year or month applied. There's a filter, maybe I have a table where I have products and regions, and then in this pivot table, I have like a different filter because this row is about the bikes products and the column is about the region Europe, for example. So there's a filter applied to this single cell. So the formula is always the same, but depending where the formula is shown, there are different filters applied. So there could be slicers in your Power BI report. There's cross filters maybe might be activated that you clicked on one of the visuals. There's maybe page filters, rows, columns in the pivot table. There's many filters available. And there's also the possibility that we change the filter context in the measure, which we'll see also later here. So the measure, yes, has to be created for one table, but the only reason is that the UI, the user interface, needs a way to present you the measures. So I have to create a measure inside one of my tables, or I could even create a dedicated measure table where no data is inside, it's only hosting all those measures. But the important part is I can move the measure around the same formula, put the same formula in a different measure, in a different table, or move the measure around. The result will always be the same. So for the measure, the measure does not care on which table it is assigned to. For a calculated column, This is not true for a calculated column. It's very important because it's then evaluated row by row of your table. So the result will be different if you just put this measure to another table, because maybe some of the columns would not exist in the other table, or there's different rows or different content. So the result will be different. For the measure doesn't care. Just takes the values from different tables, and where the measure itself is hosted does not make any difference. All those filters make the difference. So the calculation is then per item shown in the visual. That means if I have like a table, a pivot table with 3 rows, 4 columns, then this means 3 times 4 is 12, plus then 3 for the total, and the total columns, the total rows, and the ground totals is like 15 times then calculated. So it's not only one time calculated, but it's calculated 15 times. It's not done row by row unless we demand so, we ask for it, and we'll see this in a second. And the result is not saved in the model. So the formula is saved in the model, but not the result. And it doesn't make sense to persist the result in the model, because the evaluation or the result of the measure will be different in so many occasions, depending on which kind of fields are applied. The result will always be different. So pre-aggregate or pre-calculating this does not really make a sense. This is a special performance tuning where we can teach Power BI to also persist things. Then it would not calculate it only the measure, but would provide things as a calculated column in a pre-aggregated table. But this is performance tuning. Currently, we're talking about measures. Measures are not stored in the model and in the model. And they're responding to interaction, because if I change the filter, the result is not stored. Of course, the result of the measure will then change and reacting to my changed filters. And the good news here is measures behave the same in Excel and Power BI. There's no difference. So if you're going to use or providing or having users who want to use Power BI datasets with Excel, go for measures. So the margin and percentage, that's what we had troubles in with the calculate column. In a measure, as you can see here, the measure lives outside of the table. So even if I create this measure margin and percentage inside of the sales table, it does not really have the concept of a row context. So it doesn't, if I just type in my formula with sales margin, so if I omit the sum here, this will not work, because there is not one single value for margin. There's potentially many, many, many rows in the sales table with different margins. So Power BI DAX in a measure doesn't really know what to do with all those rows with different values. So we have to explicitly provide aggregation functions. So we have to tell DAX that we need a sum, or the smallest one, min, or the biggest one, max, and so on and so forth. So we cannot refer to the margin, we have to refer to the sum of the margin and divide this by the sum of the sales amount. And the good thing is, for a single row, even if there's only one row in the sales table, the sum of the margin is just the margin of this very row. So it doesn't really change anything on the lowest aggregation level. So 10 divided by 50 is 20, 45 divided by 120 is 37, 37.5, and 150 divided by 530. So those numbers are identical to what we have previously seen. But the good thing is, now we are in a measure. And measure does not have an implicit measure. This is an explicit measure. And this formula sum of margin can easily also be applied on the total, because now we have the sum of the margin, which is 205, and the sum of the sales amount, which is 670. So we end up with a 30.6. So margins, the measures, come to rescue for us if we do divisions or multiplications. So this is division. So that's the right one. So every time you need a ratio, every time you need a percentage, something like that, you cannot calculate this. I mean, you can, but you will be disappointed by the result because it will be wrong. So you cannot do it in the calculated column, and you cannot pre-calculate it in Power Query or your data source. So maybe you have a data warehouse where people could prepare those percentages, but this doesn't help, because then we load those single percentages, and then we could only calculate on those results of the percentages instead of recalculating depending on the filters. So it's very, very important. Even if you try to avoid measures, in the case of ratios and percentages, you need measures. Otherwise, you have no way of getting the right result without explicit measures. So it's very important. For the margin, this is the sales amount minus the total cost of the sales amount, minus total cost, and this is the same here. So 50 minus 4 is 10, 120 minus 75 is 45, 500 with 500 minus 350 is 150, and then again we are in explicit measure. That means this is also then, this formula is also applied on the total. So this total is not calculated this way, but this way. This is very, very important because sometimes I see people struggling with the result. So sometimes this result, a result cannot calculate it here and here. For example, I do a project for an insurance company, and there might be insurance cases where somebody claims the insurance because he or she has back problems. And there's another person, second one, with knee problems. And there's a third one with backs and knee problems. So it's 3 persons. And if I build a report asking how many people are claimed their insurance because of knee problems, it will be 2, because there's one person exclusively on the knee problem and another with knee and back problems. And if I have then another row here in my report showing who has or how many people have back problems, it's also 2. Again, because there's one person showing up now in the first and the second row. This person is showing up in the knee problem row and the back problem row. But in the total, if I count the people, it's only 3 people. And this can be confusing, and you have to really, really clear about what is the expectation of these people. One they calculate, like count how many cases they had per issue, and want to have the result down there. And then there's a trick to apply, which we'll see as the next example. But by default, I would have 2 here, 2 here, but only 3 persons here, because the implicit measure, the explicit measure, is not calculating this way. It's always calculating this way. The only difference between the 205 and the 150 is that this 150 is calculated because there's a filter on the date for the 3rd of the month. In the total, there's no filter at all. That's the only difference. The formula is the very, very same. The only difference is the filter. So I have a filter on the 1st, on the 2nd, or 3rd, and no filter at all. And that's why I see different numbers here. So a measure, by default, is never calculated vertically. It's always calculated horizontally, so to speak. So this is also a very important concept to understand. So if you now compare the calculated column and the measure, remember the calculated column has a row context. So this is evaluated row by row. So I can reach out to the price, I can reach out to the quantity, because there's a price, there's one single value for the column price for the current row. There's one single value for the quantity of the current row. So this works in the row context. In the measure, we are facing filter context. This means there is not one single value for sales amount, but there's a lot of possibly billions of sales amounts in my sales table, and DAX has to know what to do with all those rows. So we have to provide an aggregation function. For example, we want to sum the value and sum it up and then do the calculations here. So very important concept. How much time do I have left? Okay, 50 minutes. I have to speed up a little bit. So the sales amount is the other one. That's the first one where we talked about that it's the price times the quantity. If you do that here, we end up with weird numbers. So 30 times 4, maybe it's right. I mean, this is right. But at the very end, we see there's some problem in this report, because this is calculated like row by row. So it's the price and the quantity, how this is summed up. And the 2080, I mean, these numbers already wrong, but even if I don't know that those are wrongs, we would see there's some issue here, because if I have a sales amount of 122 times and 500, the sales amount cannot be 2,000. I mean, everybody would wish for that would be better news, having 2,000 of sales amount instead of 670, but that's not the true number. And we have to be true to what the data gives us. We cannot just fake numbers here. And this is like a fake number. 2,000 was never there. What's the reason for that? Again, remember, we are in a measure, and the measure is never calculated this way. A measure is always calculated this way. So it's taking up the sum of the price, which is 160. 30 plus 30 plus 100 is 160. At latest at this point, everybody has to stop and rethink. Can I sum up prices? Does this make sense? No, never. Never makes sense to sum up prices, because if I buy one product at the price of 10 and another product at the price of 100, I cannot just take 100, 110 and multiply it by the two products. This is the wrong calculation. We have to individually calculate those numbers and then sum the result up. So this is wrong. So a measure saved us during the calculation of the percentage, but has troubles or shows wrong numbers if you try to do multiplications, because we always have to aggregate the numbers. And if I aggregate the price, I'm totally wrong. There's no way of calculating it this way. So what we instead have to do is that let's rethink again. What we need here is that we have to individually calculate it for the sales table. I have to calculate the price times quantity for every single row in my sales table. So 10 times 3, 30. 20 times 1, 34, and so on and so forth. But at the very end, I cannot, for the total, I cannot sum up the prices, sum up the quantities, and then also multiply them. But I have to add up the results here. And this is also possible. There's a function called sum x. So sum x like iterator. That's what I always see. I don't know why this x is there. There's some explanations, but yeah, of course. It's this x function. There's not only the sum x function, there's also the max x, min x, average x, product x, and so on and so forth. And all those functions have always two parameters. They have one parameter. The first one is the table I want to iterate over. So if you're like into programming, this is like a for loop over a table. This would be like a cursor over a table. Of course, it's more efficient than the cursor in SQL Server, but this is the idea behind that. Or this is like a select statement over the sales table, and then select price times quantity from sales. Then I would iterate over the sales table and then calculate those numbers. And then I would wrap this like in a sum and a select sum from sales amount from subselect or something like that. So two parameters. First one is the table. Second one is an expression. As you can see here, I can refer to the price and to the quantity. I do not have to write sum of price and sum of quantity because I'm already iterating over the sales table. And if I'm referring to the price, then it's very clear. For this row, the price is 10. For this row, the price is 20. It's very clear. There's no doubt what kind of price I need per row. So now we have a row context inside of a measure. So with the sum x, those iterator functions, we can have a row context while we are in a measure. So this is now combining two concepts into one. And this is how we have to calculate calculations like that with a multiplication. We cannot do this just with sum of something multiplied by sum of something. It's a different one than iterating over the table, what we're doing here. So there's also a way, like we have the row context in the calculated column by default. And in measure, we have the filter context, no row context. But we can use iterator functions in a measure to have and force and ask for and demand for a row context inside of this calculation. So we can provide a measure, sales amount is a measure, but for the sum x, we're iterating over this table, so we have the same row context like we're having here in this sales amount. So this is working then the same, but it's in a measure. It's not stored in the system. The refresh time is not getting longer. The Power BI file is not getting bigger. It's calculated on the fly then. What's more performant in the report? We have to find out. It's really, really hard to predict performance in Power BI and DAX, I would say. So sum up. Price times quantity, or sum, and sum this up, or sum of price times sum of quantity. Only the first one is right, and the first one can be done with a measure, with the iterator function, or with calculated column and the implicit measure. The second one could also be happening in a measure, so be careful if you write multiplications in a measure. Might be wrong. For the margin, can I calculate this as a sum of the differences of sales amount and total cost, or could I calculate the sum of sales amount and calculate the total cost and then subtract it? And this is possible. So both ways are possible. One would only be available in a measure. The other one is possible in the measure and in calculated columns. And the percentage calculation, only one is right. So either it's the sum of the margin divided by sum of sales amount, or can I sum up the individual divisions, the individual results? And of course, only the first one is right, the second is wrong. And we need a measure here. The second one could also happen in a calculated column, but it's wrong. So for calculations like a percentage, like a ratio, always get into measures. There's no way around that. So please take care of your numeric calculations. also take care of the default summarization. Turn this off for all the columns you do not, where aggregation does not make sense, like the price. Doesn't make sense to add up, maybe average the price, but even that, I would first like average the, sum up the sales, sum up the quantity, and then divide it to get an average price, because the average over the price column would be the average price, not weighted by what we sold, only by the amount of goods. And this is like the wrong number. Also the calendar year month number, if you're putting in the calendar year into report and then you see like 80 million or something like that, then most probably you forgot to turn off the default summation for your calendar year. And for the others, I usually recommend to write explicit measures for them and hide the original column. In some cases, calculated columns can be more performant because they're persisted, but this is something you have to find out. Usually, by default, I stay away from calculated columns. I make measures for all of them. So next level is then 10 minutes to go, is using an iterator like the SUMX inside of a calculated column, where we already have a row context, and then we have the SUMX, the iterator function, which also has a row context. So what's happened there? Let's experiment. And when we referencing a calculated column inside the calculated column, this might be clear, but what is if you're referencing a measure which is not stored in the model inside of a calculated column? Is this possible? What happens here? So the first one, SUMX, sales price times sales quantity. That's the formula we just have seen in the measure. And if we put this into our sales table, there's two possible outcomes. And most probably the outcome will surprise you, because what we get here is that we get the 670, the sum of all the sales. So this is like the total sales in our table in all individual rows. Usually this is not what we all see here. This is not a number which is very useful, but the reason is because inside of a row context, we are inside of a row context, and the row context is not a filter. So that means if I'm referring to the sales table inside of every single row in here, it's referring to the complete sales table. It's not referring just to the current row, because the row context is not filtering, it's not applying any filters. And this might sound stupid, and I had a long time fighting against that. I would not believe that, and I would not believe in that the row context is not filtering, but it is the case. Believe me here. Make a shortcut so you have an easier life than when I started learning DAX. So for the first row, it's not only calculating 10 times 3, but it's also calculating 20 times 1, 30 times 4, and 100 times 5, and then sum this up. This is done for the first row. So basically, we have two loops here. One loop is going from one row to the other, and for every row, I'm also looping over the full table. That's why I'm seeing the 617 here. So this is usually a number we do not want to see here. So this is only for educational purposes, to remind you that the row context is not filtering. And if you're referring to another column, like the sales, if a column sales amount C for column, and then refer to the other sales amount column, this is working like expected, I would say. We have adjusted the application of the rows. This, again, usually I don't do that, because why should I duplicate the row? It's only educational purpose. So if I'm referring to another column, it's just referring to the value. But what is if I'm referring now to a measure? So let's see that I omitted the sales table, the table name here. So remember, then it means that now I'm inside of a calculated column, but I'm referring a measure. And the measure has this SUMX, sales price times sales quantity, the same formula we already have seen. So what's the outcome? If we put this formula directly into the column, we have seen that we would then receive 670 everywhere. If you're referring to a measure with the very same formula, again, this might be a surprise, because now we get like the right numbers. We get only 30 times 3 is 30, and so on. So the formula is the very same. The only difference is now the formula is wrapped inside of a measure. And this is also a very important thing. Then when we have a row context, and inside of the row context, we're referring to a measure, that DAX is implicitly transitioning this row context into a filter context when we're referring measure. And this is the reason I previously said, when you're referring to a column, put the table names there. When we're referring to measure, don't put the table names there. The one reason is that it's easier to spot, is this a column or is this a measure? Because inside of a row context, it's a huge difference what's happening here. Okay, we can also simulate the very same thing by passing in the calculate function. So if I again in the calculated column put in the very same formula and not referring to a measure, but just putting the calculate function there. And when I very first saw the calculate function, I thought, what should change here? Because calculate means calculate something, but calculate is a very, very, very powerful function. We will see in many calculations. So it's very good to learn how to use calculate because it's very, very, very helpful. And one of the things calculate does is transitioning a row context, like the row context from the current row, into a filter context. So if I wrap everything into calculate, this means now the sales table is not the full sales table, but the sales table is only the sales table for the current row. So every single column of my sales table is then as I put a filter on it to filter the sales table for this occurrence. That's why we're seeing only 30, 20, 120, and 500 here. So this might be an expensive operation, but sometimes it's necessary to do so that we can have the row context filtered on the tables. So calculate, one of the two things calculate does is to perform a transition of the row context into a filter context. So now we've seen that we have a row context in the calculated columns. We have by default a filter context on the measures, but we can, with the help of the iterator functions, we can have a row context inside of a measure. And with the help of calculate, we can change the filter context. We can transform the current row context into a filter context. So we're also having a filter context in the calculated column. So this is a very important slide, I would say. This can be very, very handy if you doubt what's happening in your calculations. So the takeaways, and I think that's the level we'll stop here. The takeaways from this is that there's a row context. Row context means that something is executed row by row over a table. And for every single row, I can reach out to the columns of this row. I don't need any aggregation. But if I then reach out to a table, like another table in some X or something like that, it is the full table because a row context by default is not passing any filters on anything else. The filter context means something is executed only once where I see the number. So if I see a number, that means it's executed there in the filter context applied to this cell in the pivot table. Or if I have a KPI in my report and I have some filters applied, cross filters, slices, and so on, then those filters go into there. So it's executed not only once, but executed one per visual item. If you have a pivot table with 3 columns and 3 rows, 4 columns, then it's executed like 4 times 5, like 20 times. And the calculated columns can easily reference other columns. A row context does not filter a table, very, very important. And a table visual, this is also very important. A table visual does not create a row context. The table visual is a table visual. It's not a table inside our model. So if I'm talking about DAX and tables, I'm referring to the tables in the model and not to a table in our visuals, in our dashboards and so on. So table visual is providing a filter context, not a row context, very important. And with calculate, we can explicitly transition a row context into a filter context, and a measure, so to say, is implicitly always wrapped into calculate. I cannot avoid this. If I use a measure inside of a row context, automatically this calculate is wrapped over it. If I want it or not, I cannot change that. This is the standard behavior. And this is the reason why when we're referencing columns, always put the table name there. So we know, oh, this is a table, a column. And in the row context, there will be no transition happening. And for the measures, we omit the table name so that it's clear this is a measure. Take care if you are in a row context, then there will be a transition happening, and also to move the measures around. So I can then move the measures to one table to the other. So maybe I decide summing up all the measures inside my sales table, and later I decide, no, I put them to an extra table. And if I'm referring to the measure with the table name, then I'm in trouble. So if I change anything here, I will break all my possibly break my DAX statements. Sometimes DAX is or Power BI is smart enough to track those changes, but you're better off not having the table name in front of the measure name. So that's how so far we came here. Are there any further questions? So the 2 questions are answered. And I think like we reached 60 minutes, right?
Yes, and we don't see any questions at this point.
So if you're just shy in asking questions right now, you can also later reach out to me or email, follow me on Twitter, you can add me on LinkedIn, stay in contact with me. And as mentioned, I already provided the slide deck and the examples with a little bit more content than I could reach today to the organizers. So just download the things, study and learn. And yeah, also thank you much for your question, Asa.
Please do make sure that you visit Data Platform Virtual Summit and explore Markus's class, which is on DAX, and it's titled as It's Time to Learn DAX. Markus is a world-renowned expert on Power Platform, and we had a lot of choices of Power BI topics that we could have delivered, but we went ahead that let's do DAX this time because it's becoming very, very popular and it is a very powerful language on the Power Platform. Markus, what are you really covering in your 8-hour session? Can you just give like a 1-minute overview?
Yeah, of course, of course. So we'll start at the very beginning. So as mentioned in one of the first slides I presented today, that DAX reached out to concepts of Excel and SQL and MDX. So that's where we start. So we start at what's similar between Excel and DAX, and then we explore some of the functions available there and how this feels. And then we get the next level and like compare how this is SQL and what's the features we're having here. So as mentioned, usually you will not join tables with each other, but there's the possibility to join things like you do in SQL, and we'll explore those functions. And then we reach to the measures, which is a concept available from MDX. So we're comparing those things and reach out to the next level. Most of the content will be also built on the very same data set which I have seen, like those 4 sales, those 4 products, and a table with 2 years. So easy stuff, because I think it's really important that we really understand those things. So if you want to learn and understand DAX, please attend my class. Most of the examples will be more educational. So now and then in between, we will do also practical DAX and apply things there. But what this class will be about is to build up the foundation so that you get confident how DAX works. Because you can always look on Stack Overflow or DAXpatterns.com. You can always look up things and copy and paste. But if you don't really understand the concepts behind, you will come to a certain moment where those DAX patterns cannot be applied, or you apply them, but the numbers seem to be wrong. And then it's hard to debug and find out. So this is what the class is about, to give you all those foundation for DAX.
Markus, myself, and our entire team, Satya, Aarti, we are all waiting for your feedback on LinkedIn. Markus, thank you very much for taking out time today for the community and for joining Data Platform Geeks webinars and delivering the very first webinar in this series. Thank you.
Yeah, it was a pleasure. Have a good night, Amit.
Thank you. Thank you, Markus. Thank you, friends. Looking for your feedback and looking forward to stay connected with all of you. Goodbye and have a nice day.